Okay, welcome back to Chapter 4. So this is the first of 4 within troubleshooting for EIGRP. So what we'll be looking at in this first video of the series is troubleshooting neighbor adjacencies. So this will be looking at why some of the issues around our adjacencies not forming correctly. So just remember that we communicate via multicast address 224.0.0.10 between the devices, and we need to have a relationship established before we'll share the lovely routing tables information between devices. So there's quite a few reasons why an adjacency will not form. So to start off with, let's confirm whether or not an adjacency has formed by using the show IP EIGRP neighbors command. And within the output of this, we'll see which neighbors we've formed a relationship, what their IP address is, what interface we can connect to them via, and our hold timer. So with this counts down between the hello packets. So it's quite a good indicator how healthy our connection is. And next to that is how long the actual devices have had that adjacency running. So some of the reasons, not all of them, but some of them, for those adjacencies not forming down. With an interface, it's got to be up and up, so it's got to be active and running. We could have a mismatch in autonomous system numbers. They will only talk to each member of the same AS group. We may incorrectly have entered our network statements under the routing protocol. It's very important if we've changed any of the default metric values, which are known as K values, that they're all the same. We may have inadvertently suppressed the routing updates coming out of an interface with the passive interface command. The link must share the same network. So if we've connected the link between two routers and misconfigured the IP addresses or subnet masks, then we won't have an adjacency form either. With authentication, we need to both have the key ID and the string match, and they must be valid for the same time duration. ACLs, if we don't filter carefully, we will stop traffic from that 224.0.0.10 address from coming through the filter. So it's very important when we do filters that we look at just not the explicit instructions on what the policy is wanting us to do, but we need to include the required ports and addressing for our protocols to function correctly. And on that, our last point there, timers. If our timers are not configured correctly, or they do not match, then we could have problems with timeouts occurring between the devices. It's always a good rule of thumb that our hello is a third of our hold down timers. Alright, so let's go through some of these examples in a little bit more detail. So the first one I think is pretty easy to diagnose if it's not up and up with the show IP interface brief. It's pretty obvious under that whether the interface is correctly functioning. Our AS numbers, on the other hand, we need to look into the show IP protocols to see what our autonomous system number is. It's quite easy to make a typo when configuring a device. Excuse me, I just had to have a sneeze. Next is our mismatch in our autonomous system. So show IP protocols will give us the output there. So the routing protocol is defined in the autonomous system. And if you scroll down a little further, it's listed again. So there's two places there that list the autonomous system number. And, this tells us our router ID, K values. It has a lot of other information within the show IP protocols that are useful for us. If we're in doubt of what's happening, Debug EIGRP packets will give us a live update as to when we send and receive packets within the device. So here in the example here we can see router 1 is only sending packets. It's not receiving any. So that tells us that our neighbour isn't sending any packets to us. And here we can see that we're sending to the AS100 group there. So that tells us that our neighbour is not part of the same autonomous system if it's potentially. Next up is our network statements. So within the show IP EIGRP interfaces on our gigabit 00, it tells us we've got 0 peers. This tells us that we're potentially in conflict with our network statements. Now, it could be the network statements wrong, or it could be a mismatch in the IP addresses on the shared interface. So that's our starting point. The other thing that could be is a passive interface, not participating. So as I said, it's the starting point, so we need to see why peers aren't forming off of that interface. I mean, lots of reasons. So one of the things we can look up is within the running config to see what our configured network statement is and our masking that's been applied. Or we can use the show IP protocols to list the routing for the networks. So this section of the output tells us what interfaces and networks we're routing. So why does that tell us what interfaces? Because we know which networks run on which interface on our device. again, show IP protocols, but this time confirming the K values for the metric. Now, when you change the metric values in use, you need to change it across your entire enterprise. Otherwise, you have problems with pathing, and you have problems with adjacencies forming, because these K values have to be the same. Here's an example of our error message that we would get. It tells us that we have a K value mismatch. And why I would suggest you use the show IP protocols for this is it tells you which ones are on, and you need to be able to put those values in correctly to align them with the next device. So you'd compare the two, which ones are true, and then adjust them on the correct device. Passive interfaces is a big one for not forming adjacencies, because its network is in the routing updates, but it's not participating in the routing process. So there's very good reasons for having passive interfaces. We improve the protocol security features by not allowing updates coming in from rogue devices, and it also reduces unnecessary protocol traffic on unrelated links. So you don't need to send EIGRP hello packets and that down to host machines. They're not going to make use of it, so turn them off, make it passive. Your network's still going to be advertised, it's just not going to send the hello packets or form adjacencies with rogue devices in that switched environment afterwards. Subnets, again, you've got to be on the same network to form an adjacency. So the error message you're going to get is a little one there that says not on common subnet. So the error message tells you what the problem is, why it hasn't formed an adjacency. And one of the reasons this occurs is people just rely on the summary of IP addressing, so the show IP interfaces brief command. It only gives you the IP address and the interface. It doesn't give you the subnet mask. And if the typo is in the subnet mask, you'll never see it using just the summary addressing. Authentication. This is where a lot of people trip over, because not only do we have to have it on, we have to have everything aligned correctly between the two. So here we can see router 1 that our authentication is using MD5 and that our keychain is EIGRP_auth. And so that's in the running config. The other way we can do it is looking at the interface in detail. So show IP EIGRP interface detail and specifying the particular interface. You'll have it listed there. Now, what you have to confirm in both devices is that it's using the correct key in the sequence of the keychain, and that the value in the key is the same. So key and the valid period is the same on both devices. So everything needs to line up. So we look at our debug output for EIGRP packets. We'll see that it's ignoring the packet, and it'll tell us the reason why it's being ignored is it's missing authentication as one possible. The other one here, ignoring the packet because the authentication is invalid. Now, debugging is a powerful tool in our arsenal. Just remember to turn it off with undebug all, and most people will use the very shortened U space all, because every time a packet arrives, you're going to have interference in your terminal session. ACLs, as I said earlier, filters, if we have permit statements all the way down, the last one is our general deny all statement that is automatically attached to every ACL. So unless you have the protocol specified to allow that group 224.0.0.10 to come in, you're not going to have adjacencies formed. So when you see this inbound or outbound going access list, and there's a value there, then it warrants checking the contents of that filter to verify that the EIGRP protocol is allowed to connect. Our timers, if we look at the output, again on the details, hello interval and hold time is listed there on the show IP EIGRP interface detail command. So this tells us what's going on. And remember, our hello interval must be faster than the hold time. If we had that set to the same, for example, it will cause too much trouble, because every time it maxed out, it'd be 5 and 5. So it's sending the hello packet at 5 seconds, and it's deforming the adjacency at 5 seconds. So rule of thumb, the hold down timer is 3 times that of the hello interval. Everybody's favourite screen. So hope you enjoy these slightly shorter format than what we did in the CCNA. I used to present the entire chapter at once in a video. These new series, I'm breaking it up into the categories that are in each chapter, making for slightly shorter videos. I hope you're enjoying the new format. Okay, thanks for joining us, and for now, it's bye from me. Until next time.